Okay, hello. Welcome to the second SOLUS webinar. This one's on recommendation systems. My name is Ramsu Sundararajan. I head R&D for SOLUS. I'm going to spend the next 45 minutes or so talking about how recommender systems are built, what are the kinds of concepts that go into it, broadly speaking, some of the broad strategies that we can talk about, and then move from there into some of what we do within SOLUS. What is SOLUS? I think most of you are aware. It's what we call a system of intelligence. So when you're looking at the problem of personalizing your engagement with customers, a broad functional taxonomy of the whole thing is to say, hey, there's a system of record that measures what people do, the system of engagement that figures out how to talk to them, and then there's a system of intelligence in the middle that largely focuses on what to do with what you know about your customers and figure out how to engage with them in a very personalized manner. Now, obviously, this is a functional taxonomy. Products themselves would overlap in terms of what they do. And one of the mainstays of what SOLUS does is get that intelligence right? So one of the mainstays of intelligence itself is a recommender system. So when you talk to people about personalization, very often recommender systems will enter the conversation. And we're all familiar with this because pretty much all of us have encountered this in some form or the other. So there's no real benefit in saying, hey, recommender systems are this great new thing and they're great and good and so on. Everybody understands this. What I want to do for a while, though, when we start, is talk about the kinds of things that underlie recommender systems or the reality of building recommender systems for businesses, and sort of, peel back the curtain a little bit to convey the real world messiness that sometimes underlies the whole thing. So let's get going. So one of the first concepts that I want to talk about is the idea that recommender algorithms and recommender systems are two very, very different things. Okay. Recommender algorithm is a very limited scientific sort of entity, right? It's an algorithm. Its job is to say, okay, I have some data. Can I use this, process it, and then figure out what to recommend to people? Okay. A recommender system, on the other hand, has to account for the mechanics of outreach. It has to account for a whole bunch of other aspects in terms of what are the circumstances under which you're talking to a customer or engaging with a customer. What are the circumstances under which the customer might respond and what exactly constitutes a response. So the plumbing for all of that and that entire system is what a recommender system is, right? So an algorithm could be a single beautiful thing that focuses on one objective and does very well on that objective. But a recommender system has a slightly larger scope. Okay, it's a fairly standard distinction of an algorithm versus a system. We're just applying the distinction here in recommender systems. And as we talk about recommender systems and what kinds of things they do, we will talk about some of the algorithms that go in, as well as the kinds of things that encompass the entire system. The next thing I want to talk about is the idea that when you have a system, we can talk about how well the system does, but it goes back to the whole idea of an algorithm versus system. Recommender accuracy can be a very specific analytical sort of metric. We can talk about, hey, I recommended 10 items. Did the customer buy at least 2 of those? Okay. Or the customer bought 3 items, where at least 2 of those in my recommendations. Okay. All of these are metrics that you can talk about, and these are very analytical metrics, and there are a variety of ways to compute. But recommender performance, on the other hand, is a multi-tiered sort of question, because you're talking about performance in terms of that analytical accuracy. You're also talking about performance in terms of, am I getting the customer to engage with the brand by getting on the website or getting on the app? Am I getting the customer to buy more? Am I getting the customer to buy more in the direction that I'm nudging him or her in? All of these questions become part of recommender performance. So there's a much larger question at play. So just like you have accuracy for algorithms, performance is a multi-dimensional sort of measurement that applies to recommenders in general. Okay, so that's another aspect to sort of keep in mind. Now, a lot of this would not be a surprise to most of you if you are decision makers in marketing and CRM. This is just to sort of reiterate some of the basic assumptions. Here's an interesting one, right? A customer might come and buy one product, but the reason to buy the product need not be, hey, I just want to buy something. People approach consumption in very different ways. Sometimes, and why does this matter to recommenders? Because when you're talking to customers, you need to understand that people approach consumption in very different ways. Sometimes, and let's take the example of eating out, right? Or rather ordering in, let me put it that way. So let's say you're sitting at home, Friday evening, 8 p.m., you haven't made dinner, you want to order in, you're opening up your favorite food aggregator app. Sometimes you're just in the mood to look at what's out there and then pick something. Sometimes you already know that you're in the mood for, say, Oriental food. Sometimes you're looking at it and you're saying, hey, I've never tried Mediterranean. I've never tried Ethiopian, right? Sometimes you're just going to go in and order something that you had already had that you know worked very well for you. So you would approach consumption in very different ways. And if you're going to approach consumption in very different ways, the way a brand engages with you in terms of what it recommends to you also needs to approach you in very, very different ways, because who knows what works, and then you have to sort of track that. So that's the whole idea of buying one product not being the same as having one reason to buy a product. You could have a variety of reasons, and each of those needs to be addressed differently. And the way that plays out is something that we'll talk about in a bit. Right? Now, this is an interesting one about a physical product and a logical product. Let me take an example of the airline industry, right? So in the airline industry, so let us say you have a flight that leaves from Bangalore to Bombay at 8 a.m. Let's say there's an Indigo flight at 8 a.m. from Bangalore to Bombay. Okay. And let's say as an airline, you've sat down and you've done your demand forecasting and all of that for this flight. Let's say for whatever reason, schedules have changed and this flight now leaves at say 8:10. Technically speaking, that's a different flight. But logically speaking, it really isn't, because the same set of customers are probably going to take that flight, which means that the demand for the 8:10 flight is pretty much the same as the 8 o'clock flight. The demand for a 9 a.m. flight may be different. But within certain boundaries, you can imagine that the logical product is something that leaves around 8 a.m. The physical product may be the flight that leaves at either 8 o'clock specifically, or 8:05 or 8:10 and so on. Now, how does this work out in, let's say, apparel? In apparel, for instance, you have a whole bunch of products. So you may have a lakh products in your product master. You could have even more, right? And you have a bunch of attributes by which you describe these products. Now, in some cases, the difference between two of those products may be fairly small. And in terms of their impact on what you talk to the customers about, it may also be very small. So sometimes it's useful to think of products in terms of slightly coarser grain, right? Just like a logical product is a slightly coarser grain than a physical product, the same thing could apply here, right? For instance, you could have, let's say, a cerulean sweater, okay? But if you're Miranda Priestley, it matters whether it's cerulean or lapis or turquoise. Okay, if you're Anne Hathaway, it's just blue, right? So it could well be that the granularity at which you look at your products and their attributes is far coarser than the granularity that actually exists. So a slightly different way of looking at this is to say that let me think of my products in terms of a combination of the attributes I use to describe them. Okay, so there could be a category and a brand and a subcategory and a size and a color and maybe a few other attributes. And then you put these together and you said, this is essentially what I'm thinking of as my product or my logical product, which is this combination of attributes. And that's a useful grain to think of, because then you could look at a variety of customers who've done fairly similar activity, and as long as what they've engaged with is either the same or very similar logical products, it allows you to understand their behavior in relation to each other much better. And this is fairly critical to recommender systems, because when you think about recommender systems, you're broadly talking about how do customers engage with customers, how do they relate to each other, and how do products relate to each other. It's broadly speaking kind of things that you look at. So if you can reduce your granularity a little bit, both from a computational standpoint, because you're dealing with less data, and also from a common sense standpoint, it allows you to understand your data a little better. It allows you to then build products that are slightly more robust to small changes. Okay, so that's what a physical versus logical product is. Now, within Solus, we use a term called the product genome. Okay, what we're referring to as a product genome is basically a unique combination of attributes that describe a product or a set of products, right? So every unique combination of a set of attributes that describe a set of products becomes a logical product or a product genome. And there could be a bunch of physical products that essentially link to a particular product. When you have a really small product master, sometimes the two can be the same. When you have a really large product master, then the distinction actually helps you computationally, logically. So another thing I want to talk about is essentially the aspect of outreach itself, right? So you have a variety of situations through which you're talking to customers when you have recommendations. One is a push-based system where you're essentially putting your recommendations into either an SMS or an email or a WhatsApp carousel, or you're putting it into some dynamic personalized link into a dynamic personalized page, and then the link to which is sent through an SMS or an email or WhatsApp. And you're essentially saying, hey, go look at this. These are our recommendations for you. Okay. And there could be a variety of tonalities to your message and so on, but this is push. The other is a pull. Now, a pull engagement is one where a customer is essentially visiting a website or an app. And once they visit a website or an app, they're essentially clicking on recommender widgets, they're clicking on product pages and looking at recommendations associated with the product and so on. Now, one of the critical factors that determine the quality of that particular interaction is the latency of response. So you want that response to be as quick as possible. So customers are browsing something, you're looking at that, they're going to a product page and you want to say below that, let's say people who bought this also bought yada, yada, yada. Okay. You want to do that in real time, but that does not mean that you have to make the calculation of these co-purchase patterns in real time. Okay, what that means when you build recommender systems is that you're asking yourself questions around, hey, I have these algorithms. Sometimes your algorithm choices depend on how much time you have to compute it, how big your computer is, and so on and so forth. You also have to sort of determine when do I compute it in order to be able to respond in real time. So can I pre-compute all my co-purchase patterns, which is the most standard way of doing it, so that you go to a product page, I pretty much know what are the co-purchase patterns I've already noticed and I know what to send to you. Right? Sometimes, however, you do need to adapt in real time. If I'm looking at your browsing behavior and adapting what I'm showing you based on the browsing behavior, then I do need to learn something about you based on your real-time behavior. So it's not always the case that the algorithms cannot be real-time and have to be pre-computed. Sometimes you do have to be real-time. So it's useful to sort of break it down and not think of it as one or the other. So far we've talked about a bunch of concepts. The one other thing I want to talk about is an aspect of real life data messiness. And really what I want to talk about here is there'll be a bunch of businesses where the majority of their business is offline. Okay. What that means is that your understanding of how your customers interact with your products is essentially your transaction master. And for a lot of those businesses, what would also happen is that for a very large proportion of your customers, you have essentially one transaction. Okay. Now, in the aggregate, you have a lot of data. So you're thinking in terms of, oh, I have so much data about all of my customers. Okay. But in reality, there are some customers for whom you probably have an embarrassment of riches because they've bought frequently, they use your app. So you have non-transaction intent data about what products they're interested in, what they browse, what they added to a wish list, what they added to a cart but did not buy, all of that. So for some customers, you have an embarrassment of riches. And there's like a good number of customers where, it's like a data desert, really. You have one data point for each of those customers, and that becomes your starting point. Okay. It's not exactly a cold start problem, but it's not tremendously far off either. So you need algorithms that know how to deal with situations where you have a lot of data and how to deal with situations where you have very, very little data. So you need that ability to automatically sort of flex. You have more data, certain strategies work better. You have less data, certain other strategies work better. How do you sort of flex? So all of those also need to be part of the considerations that go into a recommender system. Okay. So far, so good. So let's now maybe talk about what are the kinds of layers you'd have in a recommender system.